Welcome to Principles of Dynamics. In this presentation, we'll explore the fundamental concepts that govern motion, from momentum to Newton's laws, forming the foundation of classical mechanics. Let's begin with momentum. When an object moves, it possesses momentum, a vector quantity defined as the product of mass and velocity. The formula is P equals m times v, where P is momentum, m is mass, and v is velocity. Remember that momentum has both magnitude and direction. The fundamental principle of dynamics, also known as Newton's second law, states that when a force acts on a mass, it produces acceleration. Mathematically, the sum of all forces equals mass times acceleration. This principle explains why objects move the way they do when forces are applied to them. Newton's third law states that for every action, there is an equal and opposite reaction. When two objects interact, like these skaters pushing each other, the forces they exert are equal in magnitude but opposite in direction. Mathematically, the force of A on B equals the negative of the force of B on A. When two isolated bodies interact, like the Earth and Moon, they exert equal and opposite gravitational forces on each other. The magnitude of these forces is given by Newton's law of universal gravitation. The force equals the gravitational constant times the product of the masses divided by the square of the distance between them. Newton's three laws of motion provide the foundation of classical mechanics. The first law describes inertia. Objects maintain their state of motion unless acted upon by an external force. The second law quantifies how forces cause acceleration proportional to force and inversely proportional to mass. The third law states that for every action, there's an equal and opposite reaction. The center of mass is a key concept in dynamics. For a system of particles, it's calculated as the weighted average of their positions. The center of mass follows Newton's second law. The net external force equals the total mass times the acceleration of the center of mass. This simplifies the analysis of complex multiparticle systems. Finally, it's crucial to understand the conditions under which the fundamental principle of dynamics applies. Newton's laws are only valid in inertial reference frames, those in which free particles move in straight lines with constant velocity. Different observers may see different accelerations if they're in different reference frames, but the laws of physics remain invariant in all inertial frames. To summarize, the principles of dynamics provide a framework to understand and predict the motion of objects. From momentum to Newton's three laws, these